السلام عليكم ورحمة الله وبركاته والصلاة والسلام على سيدنا محمد وآله وصحبه أجمعين. Okay, today we'll continue with tahsili chemistry and I will talk about two topics, stoichiometry and gases. So let's start with stoichiometry. Okay, first you need to know the definition for mole, and mole is the amount of a substance that contains Avogadro's number of particles. So if it contains Avogadro's number of ions or molecules or atoms, this will be mole. And mole is abbreviated as MOL, and this is also the unit to measuring number of moles. And the first formula that we will use here is the formula between number of particles and number of moles. And you can use it, as we see here. I will draw this picture here. Okay, so here at the top we will have number of particles. Here we have number of moles, and here we will have Avogadro's number. And of course we know that Avogadro's number is equal to 6.02 times 10 to 23. Okay, so by this one, if a particle is unknown, it means that we need to multiply number of moles times Avogadro's number. If number of moles is unknown, so it means we need to divide particles by Avogadro's number. Okay, so this will be the first formula that we need to memorize here. Okay, then we will move into a new definition, which is the molar mass. Okay, the molar mass is the mass of 1 mole. So if you have a mass of 1 mole, this would be called the molar mass. And the unit of this one is grams per mole. Okay, and how to calculate the molar mass? The molar mass will be calculated from the units or the mass from the periodic table. So we need to use the periodic table to calculate the molar mass. So if you talk about the molar mass for Ne, so we will go to the periodic table and check the mass of Ne. It will be the unit of the molar mass for Ne. If we talk about He, so we will go to the periodic table and check the mass for He, which is almost 4. So this will give us the molar mass of He, which is 4 grams per mole. If you talk about H2, so the molar mass, it will be 2 times the mass of 1 hydrogen, which is 1.008. So almost it will be 2 grams per mole. Okay, if we talk about compounds, and here for tahsili, he asked about different compounds. He asked you to calculate the molar mass for these compounds. And the most common compounds that will be written in tahsili, like CO2 or H2O or NaOH, and sometimes also H2SO4. And if he didn't ask you to calculate the molar mass for one of these compounds, but mostly he used these compounds for stoichiometry calculation. So it's better for you to memorize the molar mass for each one of them. So if in order to use it in the calculation. So for carbon, or carbon dioxide, so the molar mass will be the molar mass for carbon, which is 12, plus for oxygen 16 times 2, because we have 2 oxygen. So this will give us 44 grams per mole. Okay, for H2O, we have 2 hydrogen and each one of them is 1. So 1 times 2 plus oxygen is 16. So this one will be 18 grams per mole. And for sodium hydroxide, for sodium, it's 23 plus oxygen 16 plus hydrogen 1. So it will give us 40. And for H2SO4, it will be 2 times 1 for hydrogen, and sulfur, it will be 32. For oxygen, it's 16 times 4, so it will give us 98. So maybe he will ask you to calculate the number or the molar mass for a substance, or he will ask you to use the molar mass to calculate the number of moles. So from this point, we will have another formula that we need to use. And this formula will be the relation between number of moles and the mass or the molar mass. Here we will have mass in grams and here we have number of moles, and here we have the molar mass. Okay, so if the mass in gram is unknown, so it means that we need to multiply more number of moles times molar mass. If the number of moles are unknown, so it means that we need to divide mass in gram over the molar mass in order to calculate each one of them, or the number of moles. Okay, let's take an example here. Okay, find the mass in grams of 2 moles of Fe, and he will write between brackets that the molar mass of Fe is equal to 56 grams per mole. So it means that I need only 2. This is the molar mass, and this is number of moles. So in order to calculate the mass in grams, so we need to multiply 2 times 56. So it will be 2 and 11 grams. Of course, remember that you are not allowed to use a calculator in tahsili, so you need to do it by yourself. But most of the time, you will have all wrong numbers except one. So you need only to multiply the first number, so it will be 2 or 12. So you need to search for the number that's starting with 2. If you have 2 numbers, so you need to continue with or calculating it up. Okay, so let's continue. Okay, we have another thing that we need to do, number of moles of ions or atoms inside a molecule. Okay, and for this one, he will give you a molecule like H2O, and he will say that you have 2 moles of H2O. So how many moles of H do you have, or how many moles of oxygen atom do you have? Okay, so here he asked about number of moles of only one component of the molecule. It will be an atom, it will be an ion, and he gives you the number of moles of the molecule itself or the compound itself. So what we need to do, we need only to multiply number of atom that's found in one molecule times number of moles of the compound. Okay, so here I have 2 moles of this compound, so I have 2. So for hydrogen, we have 2 atoms, so it will be 2 times 2, so it will be 4 moles of hydrogen atoms. Okay, for oxygen, we have 1 atom of oxygen, and we have 2 moles for the compound, so it will be 2 times 1, so it will be 2 moles of oxygen atom. Also, he could ask about this like H2SO4, and he could ask you about number of moles of hydrogen atom, or a number of moles of SO4 2 minus ions. Okay, so to calculate, and he will give you that the mole number of moles here is 3 moles of this compound. So if you have 3 moles of H2SO4, it means that you will have just compound 3 times how many hydrogen atoms that you will have. So for each one, we have 2, so times 2 times 3, so it will have 6 moles of hydrogen atom or hydrogen ion. For SO4, we have, for each one, we have 1, and we have 3. It will be 3 times 1, it will be 3 moles of SO4. And the most repeated question in this one, it will be about SE2 or Fe2O3. He asked most of the time about this one. He asked about how many moles of Fe ion found, or how many moles of oxygen found in this molecule or this compound. If he have maybe 3 moles, if you have 3 moles of this compound, how many Fe ion will be found inside this molecule? So it means that we need multiply 2 times 3, so it will be 6 moles of ions for Fe, and for O, it will be 3 times 3, so it will be 9 moles of ions. Okay, so what we need to know also about stoichiometry and tahsili, we need to differentiate between empirical formula and molecular formula. Okay, so what is the difference between both of them? First, the empirical formula is the formula that has the smallest ratio of elements or atoms. So this will give you the smallest ratio of atoms inside the molecule or the smallest ratio of all elements. For the molecular, it gives you the actual number of atoms. Okay, does it mean? What does this mean? Okay, so if we have compound like C2H6, if you look to this one, this is a molecule. We need to see if this one is an empirical formula or a molecular formula. So we need to look for the numbers for each atom and to see if this one is the simplest form or not. So this one is just not the simplest form because we can simplify this one by divided by 2, so it will give us CH3. But this one is the simplest form. The simplest form, so this one will be the empirical formula. Okay, so what about this one, which wasn't the simplest form? So this one will be the molecular formula. So if it's not and the simplest form, it will be the molecular formula. It's the simplest form, so it will be the empirical formula. We have H2O2 also. So this one is not the simplest form, so this not is an empirical formula. To convert it to an empirical formula, we need to simplify, divide by 2, so it will be HO. So this will be considered an empirical formula. But this one will be considered as a molecular formula, okay? And if we have a compound like CH3, here this is the empirical formula. So this empirical formula will be repeated twice in order to get the molecular formula, which is C2H6. So the empirical formula is just like the unit what builds this molecule. So you need to repeat this unit many times, maybe 2 or 3 or 5, okay, to get the molecular formula, which is the actual number for this molecule. Okay, how many times do we need to repeat the empirical formula? Actually, it differ from one compound to other. It may be 2 or 3 or 4. It may be 1. Okay, so to calculate the number of the repetition that we need to repeat or use it to repeat this empirical formula to get the molecular formula, we need to use the formula. We need to divide the molar mass of a compound, and this will be always given, all over the molar mass of the empirical formula. Okay, and you will have of course, the empirical formula. I will tell you that the empirical formula CH3 maybe, and the molar mass for the compound is maybe 100, and you need to calculate the empirical or the molar mass for the empirical formula and divide these two numbers. So you will get 2. It means that you need to repeat the empirical formula twice. You need to multiply it by 2 to get the molecular formula. And we will do exercise after we finish all this one. Okay. What else do we need to know about the stoichiometry for tahsili? We need to know the definition for the limiting reactant. So what is the limiting reactant? Limiting reactant is the reactant that determine okay, this one determines the amount of the product. It means this one will finish first or consumed first. Okay, so the substance that or the reactant that will be finished first or consumed first, this one will make the reaction stop, and that's why it will be determined the amount of the product. That's why it will be limit this reaction. That's why it will be called a limiting reaction. Okay, so you need to know the definition, and you need to know that this one will be consumed first or finished first. We need to know how to calculate the percent yield. And the percent yield is equal to actual yield over the theoretical one times 100. Of course, if he asks you about calculating the percent yields, he will give you the actual and the theoretical. You need only to divide the actual over the theoretical and multiply it by 100. Okay, and this percent yield is used to measure the efficiency of the experiment. So this will be all about stoichiometry. So now we will move to gas, and after this I will solve a lot of problems about both of them. Okay, now let's start with gas. So what do you need to know for gas for tahsili? First, you need to know that the pressure or the atmospheric pressure will be measured by an apparatus, and this apparatus is called barometer. Okay, and now we have different laws to measure the relationship between pressure, temperature, and volume for any gas. We have three laws actually. The first one, which is Boyle's law. Okay, and Boyle's law is the relation between pressure and volume, and this is an inverse relationship. So we will find the formula P1 V1 equal to P2 V2. First, we need to know that what's the kind of the relationship, because most of the time he will give you the definition. So we need to memorize that we will have the inverse relationship between pressure and volume, and this will be Boyle's law. Okay, and also he will give you the graph here. If we draw pressure with volume, so it will be giving an inverse relationship like this. So this will be Boyle. Okay, Charles' law. Okay, Charles' law is the relationship between volume and temperature, and actually it's a direct relationship. So it means we have V1 over T1 will be V2 over T2. Okay, and here temperature should be in Kelvin and volume should be in liters. Okay, let's go here back. I didn't say the unit. Here you can use any unit, but most of the time we will use it ATM, and for volume it will be liters. Okay, but here it should be Kelvin for temperature. We are not allowed to use the Charles law or for any gases as temperature as Celsius. Okay, if we draw here, actually for Charles we have two graphs. The first one, if we have the temperature in Kelvin, and here we will have V, and so we will have a line with the origin, and here if we have it T with Celsius and V, so we will have a line, but it will not pass in 0.00, because here if we extend this one, here it will be minus 273. And this is where we can calculate or convert between the T Kelvin and T Celsius, which is 273 plus T Celsius. Okay, so this will be for Charles' law. And the third one, it will be Gay-Lussac. Okay, Gay-Lussac's law, it will be between pressure and temperature, and also it's a direct relationship between P1 over T1 be equal to P2 over T2. So you need only to, if you want to draw the graph, so this will be temperature in Kelvin, and this will be pressure. So we will have a direct relationship like this. Okay. If we have a law that will be, or a formula that will combine the three laws, and actually that's why it will be called a combined gas law. This combined gas law will be P1 V1 over T1 will be equal to P2 V2 over T2. Okay. Now we have another law for gases, which is Avogadro's principle. So what is Avogadro's principle? It says that if you have equal volumes of gases, different gases, at the same temperature and pressure, so it means they will have equal amount of particles or number of particles. So they will have equal numbers or amount of particles. So it means number of moles will be equal. And this is very important one. So if you have different gases, okay, like H2O2, okay, and you have them at the same temperature and the same pressure, and you take the same volume, so it may be 1 liter or 2 liters, so they will contain the same number of moles. And from this, Avogadro gives us the volume of any gas under certain conditions, which will be called standard temperature and pressure. This conditions, it's called STP, which is a standard temperature and pressure, where the temperature will be 0 Celsius and the pressure will be 1 atm. Under these conditions, any gas, 1 mole of any gas will take 22.4 liters. Okay, so again, if you take 1 mole of any gas and at this condition or under these conditions, which is 0 Celsius and 1 atm, so the volume for this gas will be 22.4 liters. And from this one, we can calculate the volume for any gas at the same condition, so it should be at STP. But if we change number of moles, we will not taking 1 mole, we can take 2 moles or 3.5 or 0.5, so V will be equal to number of moles times 22.4 liters, and by this, but of course, it should be at STP. By this formula, we can calculate the number of or the volume for any gas. Okay, so the last part for stoichiometry and gases that we will use the equation, the chemical equation. And by using the chemical equation like 3H2 plus N2 will give you 2NH3. First, we need to balance this chemical equation. So to use the chemical equation, we need to balance it, and this will be the first step in stoichiometry, is to balance your chemical reaction. Okay, so this will be the first step. After this, we will use something called molar ratio. So what is the molar ratio? Is the ratio between any two substances inside the equation. So we have 3, 1, 2, 3. So the molar ratio maybe for nitrogen, it will be 1 mole of nitrogen over 3 moles of H2. This is the first molar ratio. What is the meaning of the molar ratio? It will give you the ratio between number of moles between two different substances. So if we talk about N2, so it will be 1 mole of N2 over 3 moles of H2, or 1 mole of NH3 over 1 mole of N2, and so on. So we can write different number of ratio. The number or the total number of ratios that can be written from an equation will be equal to N times N minus 1. So what is N? N is not an a number of moles, no. N here represent number of substance here inside your equation. So if I'm going to look for this equation, so if we look here, so we will have, this is the first 1, 2, 3. So we have 3 substances. So I will substitute for N by 3. So it will be 3 times 3 minus 1. So it will be 3 times 2, it will be 6. So we can write 6 ratios from this equation. Okay. And for the ratio, we will use the ratio to calculate the amount of a substance. So maybe we'll have the same equation, 3H2 plus N2 will give you 2NH3. It will ask you about the amount of moles of NH3 that will be reduced if you use 5 mole of N2. So we will use the ratio here. So I will say from the equation first, we need to write the one from the equation and then the actual one. Okay, so from the equation, 1 mole of N2 will give you 2 moles of NH3. So 5 moles of N2 will give you what? Okay, and by using this ratio, so it means that we need to multiply 2 times 5 over 1. So it will be 2 times 5 over 1. So it will be 10 moles of NH3. So you need to calculate it like this. Sometimes he will not ask about number of moles, he will ask about grams. So again, you need to convert these moles into gram by multiply this one with the molar mass. Now we will go and solve some problems. Okay. I will put this worksheet on the description down so you can see it. Okay, let's start here. I will solve some, not all of them. Okay, for number 1, Avogadro's number is equal to, so of course it will be 8, will be 6.02 times 10 to the negative 23. You need only to memorize this one. Okay, wait, because I want to write. Okay. Number of moles in 120 grams of substance with molar mass. So he gave us the molar mass and he wants us to calculate number of moles. So what we need to do, we need only to multiply number of the molar mass times, we need to divide. Again, I need to write just 1 second. So we need a formula that number of moles. If we want to calculate number of moles, the first formula, okay, if we remember that the first formula here, or the second formula here, we have mass in gram, and here we have number of moles, and here we have molar mass. Of course, so if we need to calculate number of moles, it means that we will divide the mass in gram, which is 120, over the molar mass, which is 39. Of course, we are not going to divide. We will, just round it. So this maybe, if this one will be 40, it means it will equal to 3. So we don't have any 3 here. So the most suitable one will be 4. Okay. 3. Mass of 2 moles of helium, and he gave us the molar mass. So again, we have number of moles, we have the molar mass, and we need to calculate the mass. So the mass in grams, this one is unknown. So we will multiply here number of moles with the molar mass. We need to multiply 2 with 4. It means it will be 8. So it will be C. Okay, molar mass of H2SO4. So you need only to add them together, but taking in consideration that if you have number of oxygen 4, so you need to multiply 16 with 4 first. So it will be 2 for hydrogen times 1 plus 32 for sulfur plus 16 times 4, and you need to multiply. And you need to memorize this one. It will be easier for it will be 98. Okay, moles found in 90 grams of water. So we need to calculate number of moles, and they give us the molar is a gram, mass in grams. So again, if you go back again for the formula, so the formula here, it will be mass in grams, here number of moles, and here's the molar mass. So if you want to calculate number of moles, it means that we need to divide the mass in gram over the molar mass. So the mass in gram is 90, and the molar mass of water is 18. So I will divide them. So it will be, of course, here you can try to multiply 18 with 3 or 4 or 5. It will be easier for you to find the answer. And actually it will be 5. Okay, because if you try to multiply 8 with a number to give you 0, so it will be only 5. Moles of Fe and 6 moles Fe2O3. Okay, so here we have again the number of moles, but we need number of moles of an ion or an atom inside a molecule. So it means that we need to multiply the number of the atom times the number of moles. So we need to multiply 2 times 6, so it will be 12. Which is the correct mole ratio for Fe? So we need one of these will be a correct molar ratio representing Fe. So it could be Fe with H2, or Fe with H2, or Fe with Fe2O3. So first we have 3 moles for Fe. So I need one with 3 moles of Fe. So this one will be, so I need to pick from these, okay? Now for the first one, 2 moles of Fe. No, actually we have 1 mole because this is the coefficient 1 mole. So this will be also wrong. For this one, 2 moles of hydrogen. And again, hydrogen have 4 coefficients, have 4 moles. So it will be wrong. So this one will be 2. Okay, the number of the total ratio in the reaction. Okay, I didn't write the reaction. I think this reaction will be the first, which is, okay, N2 plus 3H2. It will give you 2 NH3. And of course, this one will be 3 times 2, so it will be 6. How to calculate it? We need only to count how many substances that we have. So we have N2, 1, 2, 3. So 3 times 2, it will be 6. How many moles of NH3 will be formed by 8 moles of nitrogen? So I will go first to the equation. So we have 1 mole of N2 will give you 2 moles of NH3. So if we use 8 moles, so it will be 2 times 8 over 1, so it will be 16. Number of moles results from reaction of 5 moles of Na and N3. Okay, so again, I will use the equation first. So if we have 2 moles of NaN3 will give you, he asked about N2, so it will give you 3 moles of N2. So now if we have 5 moles, okay, so it will be 5 times 3 over 2. So it will be 5 times 3, it will be 15. 15 over 2, it will be 7.5. Okay, what is the limiting reactant? Limiting reactant will be consumed first. So all of it will be consumed. Again, he asked about here the number of moles, and he give you the grams. So you need to divide these grams by the molar mass. So first you need to calculate the molar mass for CO2, but it will be easier for you to memorize it because it's 44. So you need to divide 66 by 44. Okay, we don't have a calculator here. So what you need to do here, I will divide by 11. So it will be 6, 4 over 4. I will simplify it. So it will be 3 over 2. It will be 1.5. That's it. The relation between H2 and H2O represent, okay, I didn't think we covered this point, but I will say it. The relation between two compounds, you have the same element, but they have the ratio between the element inside the compound are different. So this will be a multiple proportion, okay? So this will be a multiple proportion. If you have two different compounds forming from the same element, but they have different ratios, this will be multiple proportion. Which of the following as an empirical formula? To be an empirical formula, it means it will be the simplest form. You need to go over the numbers, and if their numbers will not be simplified more, or if it's the simplest form, this will be an empirical formula. So here it's 2 and 2, so we can simplify this one. It's 6 and 6, and here's 6 and 5, so it will be this one. Okay, volume of nitrogen required to react with 5 liters O2. So again, we will use first the equation. So we need the relation between nitrogen and oxygen. So from the equation, we have 1 mole of oxygen will give us or need 2 moles of nitrogen. Here we have 5 moles of oxygen, and nitrogen is unknown. So it will be 2 times 5 over 1. So it will be 10. A compound has an empirical formula of Cn, so this is the empirical formula, and its molecular mass, is 78. So what is the molecular formula? To first find the molecular formula, okay, we need to find how many times this one will be repeated. It means we need to find the number that the empirical formula will be repeated, and to find this one, we have a law for this one or a formula for this one. The formula, it will be the molar mass for the compound, which is 78, over the molar mass for the empirical formula, which is carbon and nitrogen. And we know that carbon is 12 and nitrogen is 14. So it means this one will be 28. Of course, here we can divide, or we can multiply 28 by, we have here, this is 1. Of course, it's not 1. This is 3. And this is 2, and this is 5. So we can multiply it by 2 and 3 and 5 and see which number will give us. Okay, of course, for this one, it will be 3. The first step always in stoichiometry is balancing chemical equation. So again, number of moles, and he give you grams, so it means that you need only to divide the grams over the molar mass. And here he asked about BR, not BR2, so you don't have to multiply this with 2. Okay, 1 mole of a substance is equal to 17. So it means this one will be the molar mass. So this is the molar mass, which is 17 for 1 mole. How many moles found in 34? So you need to divide the mass in gram over the molar mass. It will be 34 over 17, so it will be 2. Okay, calculate the mass of Zn found in 2 moles and the molar mass. Okay, so again, to find it, we need to use the formula. So we need to multiply number of moles times the molar mass, and from this one, we will find the mass in gram. Of course, if we see the numbers here, of course, this one is very small, this one is very small, and this one only for 1 mole. So it will be this one without calculating, okay? Okay, I will not talk about molarity. Okay, let's start talking about gases. Here, a balloon filled with 2 liters gas at this is temperature, and this is V, so this is V1, and this is T1. What is the volume at T2. So it means this one will be Charles law. So it will be V1 over T1 equal to V2 B over T2. We need to calculate V2. So it will be V12 over T1. Okay, so I will multiply V1, which is 2, times V2, which is 150, over T1, which is 400. Okay, we need only to simplify this one. Here it will be 200. Okay, and here it will be 170 over 200. 0 was 0, so it will be 15 over 20. So 15 over 20. So this one, okay, it's not okay. 15 over, but it's 15 over 20. I think this one is written in a wrong way. It should be A1. So I think this one is 300, not 400. Okay, so you need to correct this one. Okay, this one is a repeated question. He give you here a graphs and he asks you which one represents the relation between volume of a gas and its temperature. Okay, so we know that there is a direct relationship between the temperature and V. Okay, so we need to take the one with the direct temperature, so it will be A. Okay, pressure of a gas is directly proportional to its temperature at constant volume. Okay, so we have the relationship between volume and between the temperature. So this will be Charles law. A sample of a gas occupies 1 liter at 100 Kelvin. At what temperature the volume will be 0.5? Again, this one will be Charles law. So we will need to multiply V2 times T1 over V1. So it will be 0.5 times 100 over 1. So it will be 50. Okay, I will go for this one. Okay, two containers have two different gases at the same conditions of pressure at temperature. So they have the same pressure, they have the same temperature. What is the number of the molecules inside each one? So we need to check the volume. Here we have 1000 milliliters and we have 1 liter. It means they have the same volume. So if they have the same volume and we have the same pressure and they have the same temperature, it means they will have the same number of molecules. So they will be equal. Okay, 33, pressure in a gas is 5 Pascal at 12 Kelvin, 200 Kelvin. What is the pressure of at 3? Again, this one will be J-Lusac, so it will be B1 over T1 equal to B2 over T2. Now we need to calculate the pressure B2, so B2 will be equal to B1 T2 over T1. Okay, so the first pressure is 5, okay, times 300 over 200. 2 zeros will be, so it will be 3 times 5, it will be 15 over 2, so it will be 7.5. The product of pressure and volume divided by temperature in Kelvin, this will be the combined. So if you have the 3, pressure and volume and temperature, so this will be combined law. The last question, the volume of 2.7 moles of hydrogen in standard condition. Okay, so at standard condition, so we can use Avogadro's number. It means that we need to multiply the number of moles, which is 2.7 times 22.4. Okay, it's a very big one, how to multiply it. So I will only multiply the first two numbers. So it will be 7 and 4. 7 and 4, it will be 8. So my answer should start with 8. So it could be 44. Of course not, because we know that 22 times 2, it will be 44. But actually we have 2.7. It means it will be much greater than 44. So it will be B.